Graphs illustrate relationships between two different things. We looked at that was a way to graph a relation, was to put it on an actual coordinate plane. In this case, they are showing us the relationship between a ball thrown from the outfield and the time it has been in the air. All right. You can see that the height depends on how long it's been in the air. Obviously, it starts where the player threw it, which is going to be about the height of, I guess, of his arm here. It goes up, and then it comes back down, presumably when someone catches it. They have your time down here in seconds. Half a second, 1, 1.5, 2, 2.5, 3. All right. And so this is a picture of a graph and what it would look like for the ball. All right. When it is thrown up and comes back down. The height would be your range. The time would be your domain. So your height is directly related to your domain or your time. How long it has been in the air is going to determine where it is on the height, all right? And so one of the ways then we're going to look and say, well, is this a function? Is there a one-to-one relationship? And sometimes it's kind of hard to tell when you're looking at a continuous graph here. One way that you can do this is called the vertical line test, which they mention in this particular paragraph here. For a vertical line test, it says I should be able to draw a vertical line anywhere on this graph and only cross it at most one time. Because if I were to cross it 2 times, that would mean that one x value would have more than one y value. And so if I look at this particular one, I can draw a vertical line anywhere on this, and it will only cross this graph once. So this is a function. If I crossed it 2 times, this would not be a function, because that would mean I would have 2 y values for my 1 x value. And so the vertical line test is one of the ways to see if you have a function. All right, so let's look at the example. State the domain and range of the relation, then use the vertical line test to determine whether the relation is a function. So if I were to do the domain and range here, domain is going to be my x values. So what I'm going to do when I'm looking at a graph to do domain is I am going to just walk along the graph and pick out my x values. So my x value here is -3. Then I have a -2, then a -1, a 0, 1, 2, and 3. So that is my domain. All right. My range then is my y values. So I'm going to start, I'm going to look at my y-axis. I don't actually have any that are down here. My first y actually starts here at the 0. And so I have 0. This one right here looks like it's at about at 1/2, right? This is at 2 on the y-axis. All right. And this last one looks like it's around 4.5. It's in between the 4 and the 5. And so that would be my range. Then it wants me to use the vertical line test to see if it is a function. Is it a function? Well, if it's a function, then that means I should be able to only cross it once. Well, if I were to go all the way where I have any points, you can see I only cross it once. There's only one point that I can go through there. All right? Look at the next one. So I would do the same thing on the next one, list my domain and range. But if I were to do the vertical line test here, so if I were to do the vertical line test, I have a vertical line here, that's fine, that didn't cause a problem, right? Vertical line here, that's fine, that didn't cause a problem. But look at this one. What's happened here? Yeah, so I crossed here and here. So while this first one is a function, this one is not a function. Not a function. It's a relation. You still have a relation. You have 2 sets, x and y's, but you do not have a function here, okay? You don't have a function. Look at this last one. Do I have a function? Yes or no? No, I don't, and you can see it immediately. I do not have a function. It's a relation, but it is not a function. All right? they've given us this relation. So they're saying for every x and y, and they wrote it in set notation, for every x and y is going to equal x plus 2. And then they gave me my domain, my x's, 1, 2, 3, and 4. And so we're actually going to make a chart here. So we're going to make a chart of our x's that they've given us, what your y should be, and then your y values. All right, and we're going to come up with our ordered pairs. So they gave us 1. Well, what you do here is you're just going to plug the 1 in. So when x is 1, y should be 3. And so my ordered pair over here is going to be 1, 3. When x is 2, well, y is going to be 2 plus 2. So my ordered pair is going to be 2, 4. And so when they give you a function, you're literally just going to plug it in to figure out what your ordered pair should be. And so now we have our ordered pairs. So if you have a function, you're going to take your x's, plug them in to solve for y's, and you have your ordered pairs. And hopefully we all know how to graph the ordered pairs. The graph of the ordered pairs should look like this: 1, 3, 2, 4, 3, 5, and 4, 6. And you can easily see that this is a function, right? This is a function. It would pass the vertical line test, no problems. No problem with this one. It is a function. All right, let's look at the next one. Example 4. We're actually jumping to example 4 here. Graph this. State its domain and range. Is this a function? They've given me the x's, which are 1, 4, and 9. They've given me what y equals. It wants positive and negative square root of x. And then what would my order pairs be? So if I plug in a 1, y is going to equal the positive and negative square root of 1. What is the square root of 1? 1. So if I have a 1, I can get a positive 1 or I can get a negative 1. They want the positive and negative square root. If x is 4, what's the square root of 4? Well, that's 2. So we're going to get positive 2 and we're going to get negative 2. And then x is 9. So what is y? 3. So I'm going to get positive 3 and negative 3. That's what it's telling me to do there. And so when I graph it, it looks like this. Is this a function? No, this is not a function. Does not pass my vertical line test. And you can see that on any one of these sets, right? We have a problem with any of these. You're going to have something that does not pass my vertical line test. And really that's kind of obvious when you see your ordered pairs, because when you plugged it in, you got 2 answers, which immediately told you you did not have a function. This last one says graph the function f of x equals negative x squared. F of x equals negative x squared. So they did not give me any x values. They told me what y equals. Remember, f of x is the same thing as y. And so I am going to have to choose my values here. So when they don't give it to you, I recommend you always choose 0 and then choose a couple negative numbers and a couple positive numbers. So like negative 1, negative 2, 1, and 2. Okay? And so if you plug these in, you're going to get something, well, negative 2 is going to give you 4 and then a negative in front of it. Negative 1 is going to give you a negative 1. 0 is going to give you 0. 1 is going to give you negative 1. And 2 is going to give you negative 4. All right? And so if I plot these, all right, when they do not give you specific numbers, you connect your dots. All right? When they do not give you specific numbers, they connect your dots. So that means it's going to be infinite. They didn't tell you what it is. So in this case, I'm going to actually connect my dots. All right. If they just gave me a list, it's just going to be dots on a plane. If they gave me a function like this without a list, it's going to be infinite. It can be infinite numbers left, infinite numbers right.